everyone. We are going to go over some features of graphs. Now, some of these we have already learned, like how to determine whether something's a function or not. We've also learned domain and range, but we will be reviewing them in this lesson as well. So if you ever need to pause the video to write down the things that I have in each of these boxes, that would probably be a good idea, so make sure to do so. Okay, we are going to get started. Okay, so we're going to go section by section. The first section, function and types of functions. So a function, remember, we learned this a couple of standards ago, but every x value is mapped to exactly one y value. And when we are trying to determine whether a graph is a function, we have something called the vertical line test that we can use to see if our vertical line is hitting 2 points on the graph, then it would not be a function. If our vertical line that we drag across our graph does not hit 2 points at the same time, then it is a function. Types of functions. There are two types of functions, discrete or continuous. Now, discrete would mean that we are dealing with a graph that is disconnected, or a series of isolated points. So maybe something like this. If I have an x and a y-axis, and I just have a bunch of random points on my graph. This is a discrete graph because it is not continuous. The points are separated and they're completely isolated. Whereas a continuous graph is when there's no breaks in your graph and it's just one continuous line or curve. So maybe something like this. That would be a continuous graph because there is no break. So we are going to be viewing various types of graphs. However, in this lesson, I believe we only have continuous graphs that we will be dealing with. So let's go ahead and let's get started on some of the problems, just certain sections of the problems. So if we flip our page, let's determine if we're dealing with functions or not. We can also look at the x and y intercepts because that's something that we've done before. X-intercept is where it crosses the x-axis, and y-intercept is where it does not cross the y, or where it crosses the y-axis. So let's first determine whether we're dealing with a function or not. So we're going to take a vertical line, such as your pencil, you can use your ruler, you can use your ID, and we are going to just simply drag it across this graph. Now for this graph, I am not seeing this vertical line hit 2 points at one time. So what that means is that this would be a function. Now, where this graph crosses the x-axis is at this point down here, which is the point 0, 0. So yes, we have an x-intercept, and that is at the point 0, 0. And where this graph crosses the y-axis is also at 0, 0. So yes, we have a y-intercept, and it's at 0, 0. Sometimes the x and y-intercept can be the same. Sometimes they may be different. But those are the x and y-intercepts for this graph. All right, we are going to save the rest of these problems. In a little bit, we'll do them. But let's jump down to number 2 and let's do the function and the x and y intercepts for this graph. So let's take our vertical line. We are going to drag it across this graph. And so far, I'm not seeing it hit 2 points at once. Still not. So this is also a function. Now, x and y intercepts. Let's look at the x-intercepts. So I see this graph actually cross the x-axis in 2 places. This place and this place. We're going to write them both down. So yes, we do have some x-intercepts. One of the locations is the ordered pair -3, 0, while my other location is the point 5, 0. Now, y-intercepts, I only see this graph cross the y-axis in one spot, and that is right here. So yes, we have a y-intercept, and that location is the point 0, 90. Okay, so we did the x and y intercepts and determined if it was a function for the first two. Okay, so now doing the vertical line test on question number 3. When I drag a vertical line across this graph, oh, it's hitting 2 points at every single point. For example, it's hitting this point and this point in this location. So since it's hitting 2 points in that vertical line, this is not a function. Okay, so now we're going to look at x and y intercepts. Now, where it's crossing the x-axis is at this point here, which is 0, 0. So yes, there's an x-intercept. Sometimes there may not be an x-intercept. Your x-intercept is 0, 0 here. And also, it's crossing the y-axis at that point too. So yes, there's a y-intercept. Sometimes there may not be. And it crosses at 0, 0. All right, jumping down to our last problem, number 4. When I take my vertical line and drag it across this graph, it is not hitting 2 points at one time. Some of you guys might say, oh, right here it does, right here it does. No, it is actually very slightly increasing at this part. So it is not hitting 2 points at that point. So it is a function. Okay, so yes, it's a function. Now let's do the x-intercepts. Now, it looks like this graph hits the x-axis at 3 places. But remember, we learned that an open dot is technically not a point on your graph. So that is not an x-intercept. So your only 2 x-intercepts are these ones that I'm highlighting in red. And so we do have some x-intercepts, and the ordered pairs are 0, 0. And 3, 0. And then there's just one y-intercept, and that's at 0, 0. Okay, so now that we have done the x, y intercepts and the functions for each of these, we're going to go back and learn about our next tables here, domain and range, which should be a review, but we are going to review it. So domain is the set of all x values. We write it in set notation, which we have learned. Remember, set notation is when we're doing like negative infinity to infinity, we would write this with the parentheses. Now, if your domain includes a point on the graph, then, let's say the domain goes from 2 to infinity, then with the 2, we would put a bracket by that 2. And whenever we're doing negative infinity or infinity, we always put the parentheses in. Let's say that it doesn't include that point, then we would just do a parentheses to infinity. Okay, so this is what set notation looks like. Now, for continuous graphs, your domain is always going to be the leftmost point and then the rightmost point reported out. And then for range, the set of all y values, we're going to also write in set notation. And for continuous graphs, it's the bottommost point and the topmost point. So let's go through and do the domain and range for numbers 1 through 4. Number 1, your domain is letter H and your range is letter K. All right. For the domain, your leftmost point has an arrow on it. So that means that it's going to go all the way to negative infinity. Your rightmost point also has an arrow on it. So that means it's going to go all the way to infinity. For your range, your bottommost point is an absolute bottom here, and it does include that point. So your range starts at the lowest point of 0, and it includes 0, so we're going to put a bracket. And then your topmost point, there's arrows on the ends of the top of your graph. So that means it's going to extend all the way to an infinity. And with negative infinities and infinities, remember we put parentheses on the end of your set. All right, so that is the domain and range for number 1. Going down to number 2. So domain, your leftmost point has an arrow on it. So it goes from negative infinity to your rightmost point, which also has an arrow on it. so it goes all the way to infinity. For the range, your bottommost point has an arrow on it, so it extends all the way to negative infinity. And then your topmost point, now it may look like this is the topmost point, however, this arrow is going to go up and up past that topmost point. So your topmost point technically has an arrow on it, so this graph's going to extend all the way to infinity. So your domain and range are the same here, negative infinity to infinity. All right, we're going to flip to the next page. We're going to do the domain and range for questions 3 and 4. For question 3, your domain, your leftmost point is this point here, which is 0. And since it runs through 0, that means it includes 0. So we're going to put a bracket, and your lowest point of your domain is 0. And then your rightmost point has arrows on the end, so that means that it goes all the way to infinity. For the range, your bottommost point has an arrow, so that means it extends all the way to negative infinity. Your topmost point has an arrow, so it goes all the way up to infinity. All right, and then question 4. Your leftmost point has the x value of -4. And since it's an open circle, that means we should not be drawing this bracket because it does not include that -4. So we draw parentheses, -4, and your rightmost point has an arrow on it, so it goes all the way up to infinity. For range, your bottommost point has that arrow, so it goes all the way up to negative infinity. And your topmost point, now this does not have an arrow on it, so your topmost point is this value up here, and that is the value that is going to be the maximum on this graph, and that has the y value of 4. And since it runs through 4, it's a closed circle on 4, so that means it includes 4, so we're going to put 4, and then we're going to close it with a bracket because it includes that value. All right. So we did the domain and the range for all 4 questions. We also did the x and y intercepts for all 4 questions, and we determined whether each of these were functions or not functions. So for the rest of the ones, we're going to go over them in another video. So we're going to start our next video with intervals of increasing and decreasing.